Linear regression, a set of machine learning models that was first introduced as a statistical concept to model simple relationships by hand, but recently it exploded in popularity thanks to the rise of computers. You can now train complicated models with lots of features, and in this video we'll explore why linear regression is the model of choice for many industries and why it is the first model they teach you in the class. Let's start with the name linear regression. Linear, in this context, refers to a model space where the predicted output is a linear combination of its parameters. Picture it as a straight line, for now at least. Regression refers to the process of predicting a continuous value, meaning the target y we're trying to learn is continuous. Let's see how that looks in practice. Our data follows a linear pattern, so it's natural to think of linear regression, plus it's the only model we know so far. To use linear regression, or any model in fact, we have to provide the machines with two things. First is a model space. This is linear regression in our case. As you learn more about machine learning models, you'll have to perform exploratory analysis on your data to know which model to use, especially as your data gets more complex. The second is the update rule. This is usually obtained from gradient descent or the likelihood estimation. The update rule is just a way to tell the machines how they can obtain the best model from our provided space. As a side note, the model space is called the hypothesis. It should be clear by now that if our choice is wrong, so will the machine's output. To understand how the machine found this result, it's important to go back to basics. The model space for linear regression can be represented with this formula. It's an equation of a hyperplane, and it mimics the dimension of the data we have. So for a simple house example, this becomes a line equation that you've known since middle school. The x here is your input data. If it's large enough, you can think of it as the x-axis. The variables here are a and b. Vary the a to change the slope. Vary the b to change the intercept. Each variation is a model that exists in our model space. Let's see how we can instruct the machines to find the best one. If our data set isn't the x-axis, but only 10 houses, then we need a method to fetch the model that is the closest to all points. There are many ways to achieve this, but we'll use the ordinary least square cost function. This is a penalty function that grows bigger the further the line h gets from our data points. So what we want is for this function to be minimized. To achieve this, we'll borrow a concept from multivariable calculus. If we expand this function, you'll realize that it only has two variables. The a and the b, the rest, are known to us, and if we attempt to graph this, it will look something like this. This is a convex function with a global minima. Finding the values for a and b that minimize this function is our objective, and we can achieve this by using gradient descent. We'll first take the gradient of the cost function. Then we adjust our variables to move slowly in the direction of the steepest descent. After initializing their values to some random number, iterate and we'll eventually land on the best values for a and b. Now plug them back in our model space formula, and we found our best model. We can now use this model to perform inference. For example, finding out the price of these new houses our agency is trying to sell. We can also use it for generative tasks, like finding out the house size our investors can buy with their current budget. I'll end this video here. We'll talk more about linear regression in upcoming videos. I have also left multiple questions for those studying engineering so they can deepen their knowledge on the topic. To answer your question as to why linear regression is widely used, because it's simple, easy to interpret, and scalable. We'll see why simplicity is key when we get to statistical learning course. If you enjoyed this style of videos and want to support the channel, you can find our Patreon in the description below. See you for now.